Hi everyone. Today we'll learn about the sequences for overhauling a gearbox. So let's start with it. Before opening the gearbox, clean the gearbox thoroughly from outside. Decouple the gearbox from motor. Put match marks at joining surfaces or look for previous marks. Drain the oil. Open the top cover and end plates. Take out the input and output shaft along with bearings, gears and coupling. Closely look for wear in bearing seat, wear in gear teeth, etc. Completely strip down all the components of input and output shafts. Be careful while taking out oil seals over keyways of shafts. Clean all the components thoroughly in kerosene and dry them with moisture-free air spray. Lubricate the bearings with lubricating oils and wrap them in clean papers. After necessary repairs and replacement if necessary, assemble all the components on shaft, then the shaft should be assembled in the gearbox. Ensure proper meshing of gears. Ensure proper direction of oil seals. Place the top cover and end plates in its proper position with reference to match marks. Tighten all the bolts with proper torque. Now let's learn about gear teeth failures. In gear teeth failures we have breakage, scoring, pitting, plastic flow, scuffing, galling, spoiling, wear, abrasive wear. So what is breakage? Breakage is caused by excessive bending stress in the root imposed by the transmitted load. It may be fatigue breakage or overload breakage. The fatigue breakage initiates as a small crack which over a large number of cycles propagates until a large portion of teeth or whole teeth separate from the gear. The overload breakage is a result of system overload greater than the design load. Scoring. It is a form of surface damage on tooth flank which occurs when overheating causes the lubricant film to become unstable, allowing metal to metal contact. Local welding is imitated and welded junctions are torn apart by the relative motion of gear teeth, resulting score marks. Generally, this type of failure occurs in high-speed application using low-viscosity oil. What is pitting? Pitting is a surface fatigue failure of gear tooth. It occurs due to repeated loading of tooth surface and the contact stress exceeding the surface fatigue strength of the material. Material in fatigue region gets removed and a pit is formed. Pit itself will cause stress concentration and soon the pitting spreads to adjacent region. Subsequently, higher impact load resulting from pitting may cause fracture of already weakened tooth. However, failure process takes place over millions of cycles. There are two types of pitting, initial and progressive. Initial pitting occurs during running in period wherein oversized peaks on the surface get dislodged and small pits of 25 to 50 micrometer deep are formed just below pitch line region. Later on, the load gets distributed over a large surface area and the stress comes down which may stop the progress of pitting. Progressive pitting is a wearing phenomena which occurs and does not stop its progression even when the tooth surface becomes engaged. We can prevent pitting by grinding and polishing the gear tooth surface, ensuring contact pattern and by reducing the contact stress. What is plastic flow? Plastic flow failure occurs in softer gear materials as well as heavily loaded case hardened gears. Latter, a narrow groove band of bright finish along the pitch line is developed. It occurs when tooth surface is subjected to high contact stress under rolling cum sliding motion. It can also happen with yielding of surface or subsurface material, use of too low viscosity of the lubricant and lack of surface hardness. When gears are subjected to highly loaded condition with high sliding velocities, the lubricant film not adequately separate the surfaces This results in localized damage of the tooth surface, referred to as scuffing. Scuffing is not a fatigue phenomena and may occur instantly, many times during early stages of operation. Its prevention is assuring uniform load distribution along the tooth flanks, proper selection of lubricant, reduce the sliding velocities in the mesh is to reduce the pitch line and sliding velocities by reducing the gear center distance and increasing face width. Galling or scuffing results from a momentary failure of the oil film, sometimes causing high local temperature and also plastic flow of the skin surface of the material. Galling often takes place when the load is heavy and oil film is not strong enough to support the load. Spalling is similar to destructive pitting. It results in the shearing out of flakes of metal of appreciable size, but it does not appear to be a condition that is caused by fatigue. It generally occurs on the softer and more ductile metals. Where is loss of metal due to the rubbing action of two surfaces moving in relation to one another when the oil film is not sufficient to separate them. Abrasive wear is due to the presence of abrasive particles between the mating teeth. This abrasive may be contamination in the oil or pieces detached from the teeth itself. So, hope so you have gained knowledge from this session. Thanks for your patience. If you like my video, then please like, share and subscribe it. Thank you.